everyone, my name is Eva and this video is going to walk through how you can find the distribution of a protocol's ownership using the Gini coefficient at any point in time with the Covalent API and Excel or Google Sheets. So if you're already familiar with the Gini coefficient, you can probably skip ahead about a minute or so where I'll actually start using the API. Otherwise, I'm going to go through a quick refresher. So the Gini coefficient is most known to be used by economists to measure income inequality. This diagram here overlays different Gini coefficients onto a world map. But the Gini coefficient can actually measure inequality among values of any frequency distribution. So for example, in ecology, it can be used to measure biodiversity, and in our case, in crypto, it can be used to proxy decentralization or dispersion of a protocol's ownership. Here is a graph of Ethereum's Gini coefficient over time. There are limitations to this metric, which I want to note. I'll probably go into more detail at the end. But in terms of how to interpret the Gini coefficient, a number of 0 expresses perfect equality, where all values are the same. For example, where everyone owns the same amount of tokens. And a Gini coefficient of 1 or 100% expresses maximal inequality among the values or total inequality. And in this case, an example would be if one person owns all of the wealth, all of the tokens. So let's now get into the API. To get started, you need to decide which token you want to look at and at what point in time. For me, I'm going to look at DHEDGE today on May 20, 2021. So I previously calculated the Gini coefficient on March 11, and now I want to do the same for May 2020. The reason for that is because I know they ran a pool 2 during this time period. I just wanted to see if there was any difference in the Gini coefficient afterwards. I don't, if anything, I would predict there would be a decrease, a slight decrease, but it didn't seem like this pool 2 really distributed the tokens that much. So let's jump into it. So the first thing you need to do is to use their class A endpoint, get block heights, and this is just so you get the block height for the date that you're looking for. So for the path parameters, you put in 1 for Ethereum. I put the start and end date as May 20th, and then the next day. You can format it as a CSV, else it'll just output as a JSON, which is also, you can work around with that. So you click try, and then you get this response. So I'm just going to use the first one here. And then the next class A endpoint I'm going to use is get token holders as of a block height. So class A endpoints, I didn't explain, but they're just generic endpoints that are available across all of Covalent's supported blockchains, and you can access them through the same API. So this endpoint in particular allows you to get a snapshot of the token holders at any block height. So let's get into it. The path parameters for this one, it's 1 for Ethereum again. The address string is the address of the token, which you can just grab off Etherscan right here. And then the block height is the one that we just got from the other class A endpoint, block heights. For the page size, I chose 100,000. It's just how many results you want. I would have been safe doing around 4,000 since DHEDGE doesn't have more than 4,000 holders, but I did 100,000 just in case, just to make sure I got everyone. I formatted it as a CSV, and then I will click try. This is the response that it output for me. I'm gonna copy that, pasting it in a blank sheet. Split it to columns so it's easier to look at. And then I'm just gonna copy the details onto the actual working sheet I'm using. This is just for myself so I know, what I'm actually looking at. I'm just gonna keep what's important, which is these. Yep, that's probably fine. Now, for the Gini coefficient, the main data that you want to look at is the balance. What are all the token balances? So I'm just going to copy that. And these numbers are not human readable, so I'm going to convert them to balance in USD. So this is in way at the moment, and I'm going to, in order to change it, it's going to be, you take that, divided by 10 to the power of the number of contract decimal, the contract decimal number, and then you times it by the price of DH, which right now is 87 cents. And I'm gonna lock that as well. Yeah, and I just got the price from here, but you can get it off CoinGecko, CoinMarketCap, any other website. So yeah, this is the balance. I might talk a bit more about how to actually do the calculation very quickly. So the Gini coefficient is usually mathematically defined based on the Lorenz curve, which is this curve here. It plots the proportion of the total income or balances of a population here on the y-axis, and it plots it against the cumulative share of people from lowest to highest incomes. This means that we have to actually put the token holders from lowest to highest value, and then we need to find the cumulative share of their the token balance as well. So that's just something to note. The line at 45 degrees represents the perfect equality of incomes, and then the Gini coefficient is the ratio between area A, which is the line between the line of equality and Lorenz curve, and the total area under the line of equality, which is 0.5. This is expressed here. So let's get into that. So firstly, we need it cumulatively. So we actually want to order the balance from lowest to highest, so we can calculate what the cumulative numbers are. So you can see that here. And then you want to get, I'm just going to have something that's really easy, much easier to do for this exercise is if you actually initialize it to 0, that will make your life a lot easier. So I'm just going to do that here. Number of people, I'm just going to start. This also helps me out a lot if I just number it that way. I can remove this filter now. Actually, I think in order to make this calculation a bit more accurate, you probably want to remove dust wallets, which are all these wallets here. Otherwise, they kind of cloud your calculations. I didn't do this for the other one, but I think it's important to do it here. I think maybe I'll include anything less than $10 as a dust wallet. So yeah. I'm just going to delete these. And then I'm going to need to renumber this. Okay, so this is our clean data. I just removed the dust wallets. If you wanted to, you could also remove the bottom wallets, the bottom accounts, which I would assume are represent DH Treasury. But for this exercise, I'm going to keep them just to see overall decentralization of a protocol's tokens, of the DH tokens. So the next step is you want cumulative population. And what that looks like is, I'll just calculate it, 1 over the total number of wallets, which in this case is, there we go. I'm going to bring that down. So what this really means is, one moment, I'm going to percent. I'm going to delete everything from under. So what this means is this first person represents 0.04% of the population, 2 people represents 0.08% of the population, and so on, until you get the last one and it represents all 100% of the population. So this is the cumulative population. And now we also want the cumulative balance. So actually we want the proportion of the balance. The proportion each balance represents. So to calculate that, we just write it. Lock that in. So this is the proportion of balance. I'm going to bring that down, and then we want the cumulative proportion of balance. And that's just continue accumulating it. And then lastly, you want to find the area under the curve. So if I actually graph this for you, we'll have a quick look at what this looks like. This is what it currently looks like. Let me make sure. Oops, not that one. This is the cumulative population. And you can't really see this, but the cumulative proportion of balances is like this. It's like there. And then this is the line of equality. The reason why is because it's like this. Okay, there we go. This is what it looks like. So this is the line of equality, and this is the Lorenz curve. You can already guess that the number is going to be very high and close to 1. But what we want to do now is to find the area under this curve. And to do that, I will make the calculations now. It's just going to be width times height. So it's this plus this by 2 times the width, which is just a shortcut, is just to do 1 over the total number of inputs, because that's just each width. It's the total width divided by that. I'm gonna go all the way down, and then to sum the area under the Lorenz, it's the sum of everything we just calculated. The area between the 2 curves here is 0.5 minus this value. And then the Gini coefficient is the area in between over the total area, which is 0.5. And that's what we got. The Gini coefficient is 0.991, which is slightly lower than the previous 0.9994. So yeah, there we go. I think it's important to note that most cryptocurrencies start with a Gini coefficient of 1. I mean, Satoshi mined the first million Bitcoin, and as adoption spreads, the Gini coefficient can decrease naturally. And usually the question isn't whether it will, but how fast it will decrease. And also how fast a project even wants to decrease their Gini coefficient in a sustainable way that also supports the growth of their ecosystem. So that's basically the end of it. I said I wanted to talk through the limitations of this metric, and I think there are many limitations, and it's largely an imperfect indicator for decentralization. But this video is getting rather long now, so I will leave that as a note somewhere. But I hope this was helpful, and And thank you for watching. If you have any questions, you can feel free to reach out. I will leave some details somewhere as well. Thank you.